Hello everyone, exercise 12.1, 7th question. Minimize and maximize z is equal to 5x plus 10y subject to x plus 2y less than or equal to 120, x plus y greater than or equal to 60, x minus 2y greater than or equal to 0, xy greater than or equal to 0. So here we have to find the points at which the function given objective function is maximum and minimum. Okay, z is maximum and minimum. So here for that we have to, first of all we have to draw the graph, right? So for the graph, let's consider these constraints, given constraints, x plus 2y less than or equal to 120. To find the values of x and y, take equal, okay? X plus 2y is equal to 120. xy, first of all put x is equal to 0. What is y? 60. When y is equal to 0, x is equal to 120, right? Now let's plot the points. 0, 60. When x is equal to 0, y is equal to 60, that is, it is the point 0, 60. And next 120, x is equal to 120, x is equal to 120 and 0, right? 120, 0. It is the point 120, 0. Join these points. So it is the line x plus 2y less than or equal to 120. Okay. Next constraint, x plus y is equal to 60. xy, when x is equal to 0, y is equal to 60. When y is equal to 0, x is equal to 60, right? That is 0, 60, it is the point 0, 60. When x is equal to 60, y is equal to 0, it is the point 60, 0. Join these points. So it is the line x plus y greater than or equal to 60, okay? Then next one, x minus 2y is equal to 0. That implies x is equal to 2y. So here x is equal to 0, x is equal to 0, y is equal to 0, right? When x is equal to 0, y is equal to 0. That means this line is passing through the origin, okay? So it is the line, okay? X minus 2y is equal to 0 is this line. So x minus 2y greater than or equal to 0, okay? Now look at the constraints. Here x plus y greater than or equal to 60. Therefore, the feasible region is outside of this line, right? That is greater than. So, x plus y greater than or equal to 60. So, this line, okay, this region. Next, x plus y less than or equal to 120. So, less than means towards the origin, right? So, the region towards the origin, okay. Then, next is x minus 2y greater than or equal to 0. That is greater than, positive, okay. So here the region is nothing but, see, the common region is this one, right? That is x plus y greater than or equal to 60, that is outside from this line, and x plus 2y less than or equal to 120, that is this region towards the origin, and x minus 2y greater than or equal to 0, this region, okay. So the common region is nothing but this one. The common region, feasible region is this one, okay. So what are the points? Corner points. See, these are the corner points. Here it is 60, 0. This point is 120, 0. This one we have to find, it is the intersection of this line and this line, right? So by solving these two equations, we will get this point. And this point is nothing but, it is the intersection of this line and this line, okay? Now let's find these points. So first of all, x plus y is equal to 60, x minus 2y. X minus 2y is equal to 0 and x plus y is equal to 60. So from this we will find x and y. X is equal to 2y. So here let's substitute 2y. 2y plus y is equal to 60. 3y is equal to 60. That implies y is equal to 20. If y is equal to 20, then x is equal to 40, right? So this point is nothing but x is equal to 20. So x is equal to 40, y is equal to 20. Okay. Next, let's find this point, that is intersection of x minus 2y is equal to 0 and x plus 2y is equal to 120. That is x plus 2y is equal to 120 and x minus 2y is equal to 0. X minus 2y is equal to 0 implies x is equal to 2y. Substitute here. 2y plus 2y is equal to 120. 4y is equal to 120. That implies y is equal to 30. If y is equal to 30, substitute here. Y is equal to 30. Then x is equal to 60. So it is the point 60, 30. Okay. Okay, now we have got all the corner points. Okay, now let's find the values of z. Okay, so corner points, z is equal to 5x plus 10y. Corner points 60, 0. Substitute x is equal to 60, y is equal to 0. So here z is equal to 300, right? 5 into 60, 300. Next, 120, 0, z is equal to 5 into 120, that is 600, right? 600. Okay. Then next point, 40, 20. 40, 20. That is z is equal to, substitute x is equal to 40, y is equal to 20. 40 into 5, 200 plus 10 into 20, that is also 200, is equal to 400, right? Next, 60, 30. 60, 30. Z is equal to 5 into 60, 300 plus 10 into 30, 300, that is equal to 600. Okay. Now here, see what is the minimum value? 300, right? Therefore, Z is minimum. Z is equal to, that is Z is minimum, the minimum value of Z is 300, at which point 60, 0. And Z is maximum at, see, 600, right? Maximum value is 600. Therefore, here maximum value of Z is 600 at these 2 points, 120, 0 and 60, 30. So, here we say Z minimum value of Z is 300 at which point? 60, 0. 60, 0. And maximum value of Z is 600 at 2 points, okay? At 120, 0 and 60, 30. At 120, 0 and 60, 30. Minimize and maximize Z is equal to x plus 2y subject to x plus 2y greater than or equal to 100, 2x minus y less than or equal to 0, 2x plus y less than or equal to 200, xy greater than or equal to 0. So here given objective function is maximize and minimize Z is equal to x plus 2y. Constraints are x plus 2y greater than or equal to 100, 2x minus y less than or equal to 0, 2x plus y less than or equal to 200, xy greater than or equal to 0. So here we have to draw the graph, right? So for that, let's consider these constraints. X plus 2y is equal to 100, okay? So here x plus 2y is equal to 100. Find x, y values. Put x is equal to 0. So when x is equal to 0, y is equal to 50. When y is equal to 0, x is equal to 100. Next, let's plot the points. Here I have taken one scale is equal to 20 units, okay? According to the values of x and y, you can take the scale. So for that, see, first of all, you find all the values, x and y values, then draw the graph, okay? So here, 0, 50, when x is equal to 0, y is equal to 50. So it is the point between 40 and 60. It is the point 50, so 0, 50, okay? Next, x is equal to 100, y is equal to 0. It is the point 100, 0 and join these points. So it is the line x plus 2y, x plus 2y greater than or equal to 100. Okay. Then next is 2x minus y less than or equal to 0 means 2x less than or equal to y. That means when x is equal to 0, y is equal to 0. That is, this line is passing through the origin. Okay, it is the line. Okay, passing through the origin. So here the constraint is 2x minus y less than or equal to 0. Okay. Then next is 2x plus y less than or equal to 200. So here take equal to find the values of x and y. X, y, put x is equal to 0. Put x is equal to 0. What is y? When x is equal to 0, y is 200. When y is equal to 0, x is equal to 100. Okay, plot the points 0 to 100. So it is the point 0 to 100. And when x is equal to 100, y is equal to 0. It is the point 100, 0. Join these points. So it is the line 2x plus y less than or equal to 200. Okay. Now we have to find the feasible region, right? So here look at the constraints. So okay, first of all let's consider this one. X plus 2y greater than or equal to 100. X plus 2y greater than or equal to 100 means the region is outside from this line, right? Greater than or equal to 100. Okay, so it is the region for this constraint. Okay. Okay. And next is, see, 2x plus y less than or equal to 100. 2x plus y less than means the region towards origin, right? Inside the line. That is here. Okay. Inside the line, that is towards origin. Okay. Next is 2x minus y. See, look at this constraint. 2x minus y less than or equal to 0. That is 2x less than or equal to y. That is y is greater than or equal to 2x. Means when x is equal to 1, y is equal to 2. Right? When x is equal to 2, y is equal to 4. Y is greater. Means the region is towards y-axis. Okay? The region towards y-axis. Towards y-axis. Okay? So what is the common region? The darkest region. Okay? So here common region is nothing but this one, right? It is the common region. So it is the feasible region. Okay? It is the feasible region. The feasible region corner points are, these are the corner points. So let's find. One is 50, 0, 0, 50, 0, 200, and these points we have to find. Okay. That is 0, 50, 0, 200 corner points, and we have to find these points. This point is nothing but intersection of these two lines. That is, let's find. One line is 2x minus y is equal to 0, and this line x plus 2y is equal to 100. X plus 2y is equal to 100. Okay. So here let's find the values of x and y. 2x is equal to y. Substitute here, y is equal to 2x. Okay. So x plus 2x, 2 into 2x, that is 4x, right? 4x is equal to 100. That implies 5x is equal to 100. That implies x is equal to 20. Right? Okay. When x is equal to 20, what is y? Y is equal to 40. Right? So it is the point 20, 40. 20, 40. Next we will find this point. It is the intersection of these two lines, right? That is, one is this one, this line, and 2x plus y is equal to 200. Okay. So from this equation we get 2x is equal to y. Substitute here 2x plus y is equal to 2x, right? So 2x is equal to 200. 4x is equal to 200. X is equal to 50. X is equal to 50. What is y? Y is equal to 100. So it is the point 50, 100. 50, 100. Okay. So these are the corner points. Now let's find the values of z at these points. Okay. So corner points, z is equal to x plus 2y. 0, 50. X is equal to 0, y is equal to 50, therefore z is equal to 100. Right? At 0 to 100, z is equal to, put x is equal to 0, y is equal to 200, z is equal to 400. Okay. Next is 20, 40. 20, 40. Z is equal to, x is equal to 20, y is equal to 40, that is 20 plus 80, 100. Next point is 50, 100. 50, 100, that is z is equal to, x is equal to 50, y is equal to 100. So 50 plus 200, 250. Okay. See here we have got two minimum values, right? Z is minimum at 2 points 0, 50 and 20, 40. So here minimum value of Z is 100 at which points? 0, 50 and 20, 40. 0, 50 and 20, 40. Next is maximum. The maximum value of Z is 400. Maximum value of Z is 400 at which point? 0 to 100. 0 to 100. Maximize Z is equal to minus x plus 2y subject to the constraints x greater than or equal to 3, x plus y greater than or equal to 5, x plus 2y greater than or equal to 6, y greater than or equal to 0. So here we have to draw the graph. So first of all, x greater than or equal to 3, that is nothing but a straight line, x is equal to 3. X is equal to 3, straight line, it is the line x is equal to 3. Then next, x plus y is equal to 5. When x is equal to 0, y is equal to 5. When y is equal to 0, x is equal to 5. Plot the points 0, 5, it is the point 0, 5 and 5, 0. It is the point 5, 0. Join these points. Okay. So it is the line constraint x plus y greater than or equal to 5. Okay. Then next is x plus 2y is equal to 6. When x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to 6. 0, 3, it is the point 0, 3 and 6, 0, it is the point 6, 0. Join these points. So it is the line x plus 2y greater than or equal to 6. It is the line constraint x greater than or equal to 3. Okay. So here we have to find the feasible region, right? So first of all, x plus y greater than or equal to 5. That is the region outside of this line, right? And x plus 2y greater than or equal to 6. So here it is the line, right? X plus 2y is equal to 6, this line. And x plus 2y greater than or equal to 6 means the region outside of this line. And x greater than or equal to 3, it's obviously this line, this side, right? That is the region this side. So common region is nothing but this one. It is the feasible region. Okay. Now here let's find what are the corner points. These are the corner points, right? That is 6, 0. Okay. And this point we have to find. See, it is the point, it is the intersection of x is equal to 3 and this line, right? That is x is equal to 3 and this line is x plus y is equal to 5. Substitute x is equal to 3, y is equal to 5 minus 3, that is 2. So this point is 3, 2. Okay, x is equal to 3, y is equal to 2. So 3, 2. And next let's find this point, that is the point of intersection of these two lines. So by solving these two equations we will get this point. X plus y is equal to 5 and another equation is x plus 2y is equal to 6. So here y is equal to 5 minus x, substitute y is equal to 5 minus x here. So x plus, let's find x, okay. X is equal to 5 minus y, substitute 5 minus y plus 2y is equal to 6. That implies 5 plus y is equal to 6. That implies y is equal to 6 minus 5, 1. Okay. So what is x? When y is equal to 1, x is equal to 4. So here 4, 1. This point is 4, 1. So what are the corner points? The corner points of feasible region are 6, 0, 3, 2, 4, 1. Now let's find the values of z at these points. Corner points. Z is equal to minus x plus 2y. At 6, 0, what is the value of z? Minus 6, right? At 3, 2, z is equal to minus 3 plus 4, 1. At 4, 1, z is equal to minus 4 plus 2, that is minus 2. So here we have got maximum value of z is 1. But here we know that the feasible region is unbounded, right? So here we cannot say what is the maximum value of z, right? Because it is unbounded. The maximum value of z is equal to 1. This 1 may or may not be maximum value of z, okay? Therefore, here we can say there is no maximum value of z, okay? That is, there is no maximum value of z because our feasible region is unbounded. There is no maximum value of z. Maximize z is equal to x plus y subject to the constraints x minus y less than or equal to minus 1 minus x plus y less than or equal to 0 xy greater than or equal to 0. So here let's find the values of x and y. Constraints x minus y greater than less than or equal to 1 is equal to minus 1 xy, put x is equal to 0, y is equal to, what is y? When x is equal to 0, y is equal to 1. When y is equal to 0, x is equal to minus 1. And here next one, minus x plus y is equal to 0. When x is equal to 0, y is equal to 0. Okay, that is, it passes through the origin. Okay, one line is passes through the origin. It is minus x plus y less than or equal to 0. And another line, that is 0, 1, it is the point 0, 1 and minus 1, 0. Okay, it is the point minus 1, 0. So, it is the line. Okay, it is the line minus x plus y, sorry, x minus y less than or equal to minus 1. Okay, see here, we observe that there is no point of intersection and this problem has no feasible region. Okay, therefore, see here, there is no point of intersection and therefore, this problem has no feasible region. Therefore, there is no maximum value for z. Okay, there is no maximum value for z. That is, since this problem has no feasible region, there is no maximum value for z.